All right, here we go. Next portion of igneous rocks, I'll be able to explain how different minerals crystallize from magma at different temperatures using Bowen's reaction series. That's right, Bowen's reaction series from your reference table, and describe how this affects the composition of igneous rocks. Launch. Imagine you're baking cookies. Mm. All right, if you take the dough out early, the outside is crisp, but the middle is gooey. If you wait too long, everything hardens. Magma works the same way, but instead of cookies, it bakes minerals into rocks. All right, question one. What do you think happens to minerals inside magma as it cools? And number two, do you think all minerals form at the same time or in a certain excuse me. All right, number one, what do you think happens to minerals inside magma as it cools? All right, so in order to make rocks, it has to cool down to become a solid. It has to solidify to do that. All right, so that magma will cool down and turn into a solid as it cools, for number one. Number two, all right, do you think all minerals form at the same time or in a certain order? All right, so minerals sometimes may take more or less energy needed to melt and to crystallize, right? Melting into a liquid and crystallizing into a solid. So they all don't have the same temperatures needed to crystallize. All right, so this is from your reference table. This is page number. Where is it? No, that's not it. Here we go. This is page number 13. All right, the Bowen's reaction series is a model showing the sequence in which minerals crystallize from magma as it cools. This shows at least two branches. We have continuous and discontinuous series. And we have one more branch too, down below. All right, but we have two series up here, discontinuous and continuous. I made a series for the bottom as something separate. It's not on the reference table, but might be easier to understand. All right. So first, let's go with the discontinuous series. Now, discontinuous means that it's not continuous, right? And that's quite obvious, right? We have a series of minerals that will begin to crystallize as the magma begins to cool. So we have a very hot substance of magma, and if there is olivine in that mixture of a liquid, it will begin to crystallize at those very high temperatures. And then after olivine crystallizes, then you have pyroxene, then you have amphibole, and then you have biotite mica, all right, for all this stuff. All right, that's going to be your discontinuous series going down. All right, on the other hand, your continuous series is on the right-hand side. All right, the continuous series includes plagioclase feldspar, and this is going to be from calcium rich to sodium rich. So on the right side of this, we have the same mineral called plagioclase feldspar. Here we have a total of 1, 2, 3, 4 different minerals. Here is just one. So the first to crystallize for this one mineral is calcium rich plagioclase feldspar. That's going to be at your highest temperatures. And as the magma cools from the highest temperature, it becomes more sodium rich plagioclase feldspar. All right, the bottom portion, I call this the bottom kind of series. All right, but the bottom portion here is not the, I guess it's still kind of discontinuous, right? Because you have three different minerals, but we have the bottom portion of the series are the lightest minerals in color of potassium feldspar or K feldspar, muscovite mica, and then quartz. All right, so quartz needs the coolest temperatures to crystallize, and that should be the last thing to crystallize. Olivine being first, or calcium-rich plagioclase feldspar being first, and quartz being officially last. All right, so temperature is a key thing here. We have our highest temperatures at the very top of this section here at 1400 degrees Celsius, first to crystallize, right? Because you definitely need hot temperatures to make the rock into a molten state. Right? And then the lowest temperatures is 650 degrees Celsius, and quartz would be the last thing to crystallize once the mass cools down and solidifies. All right, Bowen's reaction series still, right? We have high temperature minerals, for example, olivine, pyroxene form first and are mafic, rich in iron and magnesium. All right, I'll explain to you where that is located in a bit. Next, low temperature minerals, for example, quartz and muscovite and potassium feldspar, form last and are felsic, rich in Si, which is silicon, and Al for aluminum. All right, we have our igneous rocks. We have our olivines and calcium-rich plagioclase feldspar can result in our ultramafic rocks. All right. We have our pyroxenes and getting more sodium rich. All right, so like the visualization here is good too. All right, so we have a lot of calcium feldspar, Ca, and a lot of olivine. So it's dark in color. And then the bottom portion is light in color. So we see color as being a key thing here for that last column. And we have the additions of the new materials, right? We have olivine's gone, and we have pyroxene, and the calcium is becoming sodium rich. Then we have biotite mica. We have amphiboline here, right? We have two different minerals, and now we have sodium feldspar. Oh, sodium plagioclase feldspar. Last one down below, we have the lightest ones in color. All right, that's going to be your K feldspars, which is potassium feldspar. We have muscovite mica and quartz. And that's going to be your felsic rocks that are rhyolite and granite. Mafics are your dark rocks. Ultramafic is really dark rocks. Intermediate, it's in the word, it's right in the middle. Andesite and diorite, those are two rocks that are considered intermediate in color and texture. All right, so we have different rock types. We have basalt and gabbro, right, which is oceanic, right? That's going to be mafic, olivine, and pyroxene. We have our intermediates of andesite and diorite that will contain some amphiboles and plagioclase feldspar. And that plagioclase feldspar is becoming, it's kind of like in the middle between calcium rich and sodium rich. Last one, rhyolite and granite. That's your felsic. That's going to be quartz, potassium feldspars, and biotite. All right, now the bottom portion is still connected to the Bowen's reaction series, but kind of in a different way. All right, so this is showing now, just like the Bowen's reaction series, right? It tells you that these rocks are mafic, and these rocks are intermediate, and these rocks are felsic. Same thing here, right? You have your ultramafic rocks, your mafic rocks, your intermediate rocks, and your felsic rocks. All right, your ultramafic rocks will be rich in olivine, right? And you would have some calcium-rich plagioclase feldspar and some pyroxenes in there. Your mafic rocks is calcium-rich. There is some olivine in it. There is some pyroxene, some amphibole within these rock samples. The intermediates, right, is becoming more sodium-rich, plagioclase feldspar. There is a little bit of quartz in these intermediate rocks. There is some amphibole. There is some pyroxene. Very little amounts of olivine now. Very little. We do have some biotite, mica. And then we have our felsic rocks, granite and rhyolite. We have a lot of quartz. We have potassium feldspar. We have sodium-rich plagioclase feldspar. Again, these are the last ones to crystallize and the lightest ones in color. We have muscovite mica. And we do have some biotite mica in there. And some amphibole as well. All right, the other key thing is we have increasing silica, right, going to the left here. So your felsic rocks are high in silica, and the ultramafics are very low in silica. Right, SiO2. Si stands for silicon. O stands for oxygen. This is what we call a silicate mineral. Next, your felsic rocks will have high amounts of potassium and sodium, right, for felsics. Your ultramafic would have very low amounts of potassium and sodium. Down below, the third one down, we have our felsic rocks being low amounts of iron, magnesium, and calcium. Our ultramafics are really high in iron, magnesium, and calcium. Right? It increases from left to right. Last one is the temperature. Right, again, olivine is the first to crystallize. Quartz is the last to crystallize. Right, temperature at which melting begins. All right, so we have hot temperatures for ultramafic rocks. And once the rocks begin to cool, that will begin to crystallize out first. Olivine and your calcium-rich plagioclase feldspar. All right, the cooler temperatures here for quartz and potassium feldspar and muscovite mica, right, are dealing with lower temperatures and the last ones to crystallize. Oh, and we have one more slide, sorry. All right, last one here is magma evolution. All right, so at mid-ocean ridges, where we have our oceanic crust, we have our mafic type of rocks. Mafic meaning basalts, right? Or could be gabbro. At subduction zones, we have more of the intermediate rocks. The intermediate rocks are going to be your andesites and your diorites. Two felsic rocks, which is going to be the lightest colored rocks. Your continental crust is going to be your felsic rocks, which would be your lightest color rocks. That's going to be granites and rhyolites. All right, that will conclude this last lesson on igneous rocks. And please take a few questions on Nearpod. I'll give you guys the code. All right, have a great night and thank you. Have a great day, excuse me, and thank you.